Hello, this question is about filtration. The question is, a laboratory filter has an area of 0.1 square meter, operates at a constant pressure drop of 400 kilopascal and produces the following results during a test on filtration of a slurry. So after 300 and 1800 seconds, the volume of filtrate collected is 19 and 63 liters respectively. The first part of the question is calculate the time required to collect 1.5 cubic meter of filtrate during filtration of the same slurry at a constant pressure drop of 300 kilopascal on a similar full-scale filter with an area of 2 square meter. And the second part of the question is calculate the volumetric flow rate of filtrate at the end of the filtration described in part A in cubic meter per second. Okay, so you have now the data. So you have here, you can make a table here. Okay, so the volume of the filtrate basically collected in cubic meter is 0.019 cubic meter and 0.063 cubic meter, and the time in second is given, that is 300 and 1800. That is given in the question. So using this data you can calculate the parameter T divided by V, okay, in the unit of second per cubic meter. Okay, so you need to divide time by the volume, and for that then you will get 15 789 here, and for this one you will get 28571. Okay, so using this data now you can obtain the equation of a linear line connecting these 2 points. Okay, so because you have V and T divided by V for 2 points, and then you can calculate the linear line basically connecting these 2 points, and that equation will be equal to T divided by V equal to 290 500 V plus 1026.9.5. So that is the linear equation connecting these 2 points. Okay, so if you compare this equation now with the general equation of the filtration under the constant pressure, that is T divided by V equal to mu alpha CSV divided by 2A2 delta P plus mu divided by A delta P times Rm. So if you compare these two equations, you see they have the same format. Therefore, you can equate this one equal to this coefficient and this one equal to this number. Okay, and if you do that, basically you will write mu alpha CSV, mu alpha CS divided by 2A2 delta P will be equal to 290 500, and from this you can calculate the value of mu alpha CS as 290 500 times 2 A2, and we know the area is 0.1, A2 will be 10 to the minus 2 times 2 will be 0.02 times delta P, and delta P here is 400 kilopascal, which will be equal to 2.324 times 10 to the power of 9. So that is the value of mu alpha CS. You can do the same for the second part, that is mu divided by A delta P Rm should be equal to this number, that is 10269.5, sorry, 0.5, and then from this one you can calculate mu Rm will be equal to 10269.5 times A, that is 0.1 given in the question, times delta P, and delta P was 400 kilopascal times 400 kilopascal, and that number will be equal to 4.11 times 10 to the power of 8. Okay, so basically from this data given, first you obtain the equation, linear equation connecting these 2 points, and then you compare this line with the general equation of filtration to calculate basically the parameter mu alpha CS and mu RM. So now you have these two values, okay? So now if you use again the general equation for filtration on the constant pressure, that the equation was as we wrote before, T divided by V equal to mu alpha CS divided by 2A2 delta P times V plus mu A delta P times Rm. But now you have the value of mu Rm and mu alpha CS. There, if you substitute those values here, you get T divided by V equal to 2.324 times 10 to the power of 9 times V divided by 2A2 delta P plus mu Rm, that is 4.11 times 10 to the power of 8 divided by A delta P. So now in this section 1, basically the question is calculate the time required to collect 1.5 cubic meter of filtrate, so that V will be 1.5 under the constant pressure of the 300 kilopascal. So you have this one, and the area of 2 cubic meter. So everything will be known except T, which is the question. So you can simply calculate. So basically here you can write from this equation, you can write T will be equal to V times the rest. V is 1.5 cubic meter, so 1.5 times 2.324 times 10 to the power of 9 times V, that is 1.5 divided by 2 times 4 times delta P here is 300 kilopascal, 300 kilopascal plus 4.11 times 10 to the power of 8 divided by A, that is 2 times delta P, that is 300 kilopascal. And that will be equal to 3206.25 seconds. Okay? So that's the solution to the second part of this question. And then the last part, they calculate the volume flow rate of the filtrate at the end of the filtration described in part A, the part I, in cubic meter per second. So you have an equation here, dV over dt is equal to A delta P divided by mu alpha CS V divided by A plus Rm. That is the general equation for filtration, okay? And we know from the previous section that mu alpha CS, we have the value that is 2.324 times 10 to the power of 9, and then we know mu Rm is equal to 4.11 times 10 to the power of 8 from the previous section. So and then so you have the delta P, that is 300 kilopascal, you have the A, that is 2 square meters. You plug everything, you can then calculate the dV over dt, which is the volumetric flow rate, okay? So therefore dV over dt will be equal to 2 times 300 kilopascal divided by 2.324 times 10 to the power of 9 times 1.5 divided by 2. Why 1.5? Because V is 1.5 divided by 2 is the area, plus mu Rm, and mu Rm you know 4.11 times 10 to the power of 8. Okay, and that will be equal to 2.78 times 10 to the minus 4 cubic meter per second, and that is the volumetric flow rate with the unit of cubic meter per second, and that's the solution to this question.